Hello everyone, so welcome you back to Ashok tutorials once again. So here we are going to continue the mathematics. All right, so pedagogical issues. So this is the second video of paper 1 mathematics. So let's continue. So inductive reasoning in mathematics. What is inductive reasoning in mathematics? Let us try to understand that. So inductive reasoning in mathematics is a method. What is this? It is a method, all right, of what? Of deriving general principles or conclusions based on a series of specific observations or examples. So by using a series of calculations or by using a series of principles, we come to a conclusion. All right, we come to a conclusion, and this method is known as inductive reasoning. What does it involve? It involves making observations about a specific set of cases and then using that information to make generalization or predictions. So what is involved here is that making certain observations. All right, we make certain observations about specific set of cases, different type of cases, and then we come to the conclusion by generalizing it or predicting it. All right, so inductive reasoning in mathematics, let us see how does it work. So first step is observation. So in order to carry out inductive reasoning in mathematics, the first and foremost thing to do is observation. So what is observation? So you start by observing a pattern or trained in a specific set of mathematical examples or data. So how do we start it? We start it by observing. See, in science and maths, the most important fundamental fact which we should know and practice always is what? Is that it is dependent. It is like the maths and science, they are dependent on observation. So if you are somebody who is observant enough, who is having a good presence of mind, who can analyze things, then maths and science becomes a child play for you, right? So let's go to generalization. You then make a conjecture or hypothesis based on the observed patterns. So whatever observations you have made, what will you do? The observation you have made or the hypothesis which you have proposed. All right, so all right, note the hypothesis, but on the observation made by you make a hypothesis or a theory. All right, and this hypothesis or this theory is usually expressed as a mathematical statement. So whenever we study mathematics, then physics, whenever we come to the different formulas, we come across all these, right? Yes. Then testing. To confirm your conjecture or to confirm our hypothesis or theory, what we have to do, we might test it with additional examples or data points. So what do? Before we declare it to the general public, we have to analyze it, we have to prove it, and then only we can make it available or make it confirmed to the public at large, right? If your conjecture holds true for all tested cases, it becomes a strong candidate for a mathematical theorem or principle. See, in mathematics we have studied a lot of theorem, right? For example, Pythagoras theorem. So we have studied Pythagoras theorem, right? So you know, it does not come by one scientist, as is the case in chemistry. So the discovery of atom, it does not come at once. So there was one scientist, then again there was another scientist, then again another scientist. So several scientists are involved, right? And then finally we come to the conclusion or the generally accepted formula, and that is accepted, which is true by the general public, and it is utilized in our day-to-day life, right? Now proof. However, in mathematics, what happens? Inductive reasoning alone is not sufficient or enough to establish the truth of a statement. See, in mathematics, since everything we do is by proving it, right? We have to prove it. Whatever we say in mathematics, we have to give the proving, we have to prove it, right? So inductive reasoning alone will not help. So to do that, you need deductive reasoning as well. See, inductive reasoning and deductive reasoning are side by side, it goes side by side, all right? So it does not alone includes the inductive reasoning. On the other hand, it involves the deductive reasoning as well, which involves providing a rigorous proof based on established axioms and logical arguments. All right, axioms and logical arguments. Yes, dear candidate, of Mtet, I would like to request you, see I forgot to add up what is this axiom, so please try to find out the meaning of this axiom and please try to read a little bit about it, and it is important. All right, this axiom is important, so I forgot, I missed out this point, so kindly do it. Now let us discuss conceptual and procedural knowledge in mathematics. So definition: conceptual knowledge in mathematics refers to a deep understanding of what? Of the fundamental concepts and principles that underlie mathematical ideas. So whatever we do, whatever topic we study, whatever chapter we study, the first and foremost thing is the building of concept, right? We need to understand that what the writer is trying to tell us, right? What knowledge is being imparted to us, what are the things which we need understanding, deep understanding of. So all these things need to be taken care of. Now after definitions comes the example. Then we give the example: understanding the concept of numbers, variables, functions and geometric shapes at the fundamental level. So we give different type of examples. We have different type of examples like geometry. Triangles are there, circles are there, parallelogram are there, trapezium are there, rhombus is there, right? So different shapes. Then what we have numbers, right? Then we have variables, a, b, c, x, y, z. Then functions, right? Different functions we have. So this is the second step. Then importance. Now what is the importance of this conceptual knowledge? Conceptual knowledge is crucial, important, because it enables students to grasp the essence of mathematical concepts and apply them flexibly in various problem solving situations. It allows for a deeper and more holistic understanding of what? Of mathematics. So see, why is this important? This is important because it provides the student an access. It provides the student an opportunity to flexibly apply whatever he or she has learned practically in her or his subject or area of interest. All right. Now procedural knowledge. So here also comes the definition first. So procedural knowledge in mathematics involves knowing how to perform specific mathematical procedure, algorithms or operations. So we need to know how are we going to know, or how are we going to perform the specific mathematical procedure. What is the procedure, what is the step, what is the method we are going to follow? We need to know that the different algorithms involved and what are the different types of operations involved there. Now example: knowing how to add, addition, subtraction, multiplication or division, right? Solve equation or perform calculus operations. See, from the very basic, that is, I think from class 1 itself we start learning the multiplication table, right? So why? Because this is very important. Then step by step we learn the operations, right? First of all we learn the addition, then we learn the subtraction, then we learn the multiplication, and eventually we learn what? The division, right? The division. So these are the different operations, mathematical operations which we learn. Now what is the importance of this? So we'll see. Procedural knowledge is essential for carrying out mathematical calculations and solving problems. It provides the practical skills needed to work with mathematical concepts effectively. See, mathematics is a subject which is not connected directly with only the theories. So it is something in which the theories of course is provided, but however that theory is proven, right? We have different theorems and along with the proof. So mathematics is a subject in which theory alone does not work, but practical knowledge is also needed, right? So why needed? Because at the end of the day what we are going to do is practically only, right? We are going to practically apply the formulas, the concept, the knowledge which we have gained by studying mathematics in our real life situations. So now let's come to the conclusion that, in summary, inductive reasoning helps in discovering patterns and making conjectures in mathematics. So what does inductive reasoning help in? It helps in discovering what? Discovering the patterns, right? Discovering the different types of patterns and making conjectures in mathematics, while conceptual knowledge focuses on understanding the underlying concept. So conceptual, by the word itself, conceptual, you understand that it has something to do with the understanding, right, of what? Of the concepts. And procedural knowledge deals with the practical mathematical skills and operations. See, procedure. When we talk about procedure, we understand that it has something to do with the doing, right, the activity. How are we going to perform it? So the different skills and knowledge needed in order to perform those operations, basically of addition, subtraction, multiplication, and division. Also there are different types of calculations, right? You know that very well. Calculus is there, trigonometry is there, but we will not go up to that high level. A well-rounded mathematical education combines these aspects to foster deep and versatile understanding of the subject. So a well-rounded mathematical education combines these aspects to foster deep and versatile understanding of the subject. So this is what it says, is that it says that a well-rounded mathematical education, so whenever we are educating students on the subject mathematics, it has to combine with these aspects. Why? So that it foster a deeper understanding of the subject and versatile nature of the subject, and the student build the concept, they know the procedure, and they know how and when to apply whatever they have learned. All right, so this was the pedagogical issues of mathematics. It was the pedagogical issues or something in mathematics, right? Yes, if I'm not mistaken, pedagogical, it was something that pedagogical issues related to mathematics. So you know, we have not yet started with what, with the calculations, with the solving of the problems, because first of all 15 marks will be given for pedagogy of mathematics. So there we are concentrating now. So once your pedagogy is strong, you know, everywhere you get marks, be it language, be it science, be it maths, be it social science, be it English. So any subject, be it environment, be it pedagogy to pedagogy, right? So you get marks everywhere. So once your pedagogy CDP is strong, you score very well and very good marks. All right, so trust me. So please try to improve your pedagogy CDP. Right, so I think this is all in this video. Thank you everyone for being here. Thank you.